assuming you have this as a typical graph, then look at it. The graph is always in this form, square form, the lines. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines make 2 cm in the standard graph. That's red color graph. You have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines here also make 2 cm here. Now, in our case here now, the scale you are going to use for that particular plotting should be 2 cm to 0.5 units on T square axis, so that you have a lengthy graph, because your highest value is around 3. So you can't use 1, 2, 3 to be too short. So you extend it, so you have at least 2/3 of the graph, like I told you. Then for this side, you can use 10, 20, 30, 40, 50, 60 to 90. I can accommodate that one. Then, if you now want to know the value of each small line here, it should be this 0.5 divided by 10 lines, which will give you 0.05. 0.05 times 2 is 0.1, which means for you to read every 0.1, you have to count 2 small lines here in this axis. For example, 3.6, this 3.61, just stop at 3.6 when you are plotting. Approximately 3.2, here 2.9 when you are plotting. So to plot 3.6, what you do is you reach your 90, as you have 90 here, 90 versus 3.6. How do you get 3.6? After 3.0, you will now have, because here will be 0.5, 1.0, 1.5, 2.0, you'll be adding 0.5 in your scale, it should be consistent. Then to reach something like 3.6, after reading 3, from 3, you now count 2 lines for 1, 4.1, 2 lines 3.1, 4 lines 3.2, 6 lines 3.3. You continue counting small lines, which means you get about 12 small lines again to get 0.6. So after 3, you count 12 small lines, which will give you 0.6, 0.6. You add up. You continue like that. Here 3.2. After 3, that's 80 versus 3.2. After 3, you count 2 small lines to be 3.1. Another 2 small lines, 3.2. You continue like that for all. Then after plotting the graph, you now have your points like this. Your points with something like this all over. Having this point now, you make a straight line with your ruler. The line may cut any point. It must not be through the origin. Then this is your slope. Triangle, choose a slope. Right angle triangle. Delta T square, delta L. Now, from here, from this point now, you get maybe your y2, which is the figure you have there. Then from here, follow this one to this axis, you get your y1, that y2 minus y1, to get the gap here. Then you now come to this place over delta L, thread this one down, wherever it is, write it, that's your x2. Then from here, this point, trace this down, wherever it lands, gives your x1, you subtract. So whatever you have here, over you subtract y2 minus y1, get the gap here, that's the change. x2 minus s1, you get the gap here, that is delta L. Then you have your value. Then you divide your calculator and get your slope. Then I put on evaluation. If they ask you for intercept means where the line cuts the axis. If intercept, just tell them that intercept means where this line cuts this axis is the intercept on the vertical axis. If the line cuts here, it is the intercept on the horizontal axis. So with this, you can put them through. Thank you.